So in this tutorial, we're going to be learning how you can create a realistic ragdoll from scratch using the game animation sample project in Unreal Engine 5.5. We also cover how you can be able to make the character stand up after ragdolling, and also set up these moving platforms in order to test our ragdoll collision settings and behavior. So we're going to start with the configurations of the physical asset. So we're going to search for PA underline UFN. You're going to double click on this one. And as you can see here, we already have a physics asset set up. So I'm going to be firstly explaining what are these, what are the components integrated into this physics asset. So we're going to start with the physical asset. So what is a physical asset? Each character in Unreal Engine 5 or 4, it has its own physical asset, which defines the collision shapes and properties used for simulating ragdoll behavior. And these physical assets contain the physical body shapes, as you can see right here, for each bone in the skeletal mesh. So you can think of them as the bones of the physics simulation. And they basically represent each body part of the character, and the physics body will determine how it will behave when it collides, falls, or interacts with other objects. So in here we have the physical body shape. So here we have a sort of like a sphere. Here we have a cylinder. Here we have a rectangle. So they are basically primitives, collision shapes assigned to a specific bone. And by assigning the right shape and size, you'll help Unreal Engine accurately simulate how each part of the body should collide with the environment. So these shapes are the foundation for realistic ragdoll motion, and without them, the engine wouldn't know how to approximate the volume and boundaries of each limb or body segment. If you take a look here, we have the constraints. If you click on those, you have to be a little bit distant to be able to click on the constraints. So the constraints, as you can see here, they are basically represented with these sort of like arrows representing the direction of where they are placed in the body, right? So if you click on them, like I've done here, as soon as you click on them, you're going to be able to see that here it says constraint head and the next 01. It means that I've already clicked on the constraint. And basically, what are constraints and why are they important? So the constraints, they define how each physical body shape can move relative to others. And they include the angular limits, which you can access by scrolling down here on the details panel. So we have the angular limits and the swing 1 motion, the swing 2 motion, and the twist motion, right? So the angular limits, it defines how far a limb can rotate from its default pose, right? And the twist limits, it controls basically the rotational twist around the bone. So if you click here on, if you have the constraint selected and click here on simulate selected, yeah, I have this constraint set up differently. So let me just do, yeah, I have to reset this. Sorry for that. Simulate options, there we go. So as you can see, when you simulate that and hold the left control and press the right mouse button and try to move the head, as you can see, the head barely moves because we don't have set up the limits for doing so, right? So if we set it to be locked, it's barely going to move at all, right? If we set it to be free on the swing 1 motion, and we get to simulate the selected, as you can see, it's only going to swing on that specific axis, right? And the head is going to be very Very, very strange. Now, you also have the options here, which is another options, which is called Angular Drive Mode. If you click on Twist and Swing, and click here on Twist and Swing, and Simulate Selected, as you can see, before you used to rotate and like continue to spin and twist the head, right? But now if you let go of the head, as you can see, it's always going to go back to its initial position, right? Even if you try to simulate a animation here, the head is going to always try to maintain its natural position if you have the twist and swing option enabled. So that's what it does. Let's go back to the reference pose here. And that's basically about it. We're going to use the twist and swing for other constraints as well. I think for most of the constraints. And let's block and limit the swing one motion. And let's completely lock. And now let's try the swing two motion and see what happens. So if you try to simulate now, as you can see, the character is going to rotate his head like 360 degrees on that specific axis. And now if we try to do let's lock the swing to motion, and let's try the twist motion. Now simulate selected. As you can see, the head can now rotate 360 degrees like an owl. So yeah, those are essentially the tools that you need in order for you to be able to build your realistic ragdoll. Of course, we have other things like setting up the collision so that the body can also collide with other parts of the body, like the body, they can collide with each other. But I'm going to be teaching you guys later how you can do that. It's very easy as well. So just to recap everything, a physical asset, which is this one right here, it contains the physics bodies and constraints for each bone. And the body shapes are the collision primitives representing each segment of the character's mesh, right? And the constraints, they control how those shapes can move, rotate, or twist relative to one another. So just by tweaking these parameters and properties, it helps you to achieve a lifelike ragdoll simulation. Okay, so now if you want to, I already have a ragdoll set up right here, but before that, I'm going to lock everything as it was before, because for some reason Epic Games didn't set up this specific physics asset in a way that it's believable. So if you go to simulate the pelvis, which is going to simulate the whole body basically, the ragdoll looks like this. If you try to pull it down, it's just going to be like that. It doesn't look realistic, right? I think it's trying to stand up because I'm not simulating the root as well. So it's going to try to stand up like this. But if you try to simulate the root, I think it's going to work now. Yeah. So as you can see, the ragdoll is not really realistic at all. Like the limbs, they don't rotate or twist realistically. And I already have a ragdoll that I have already set up all the settings, which is this one right here. And if I try to simulate the pelvis, let me see if it's this one right here, pelvis. Why it's not working? Yeah, there you go. Now, as you can see, this one behaves like a real ragdoll. And if you want to copy the same settings, then I'm going to show you basically how you can do that. So if you want to copy the settings of mine, you can as well. So for the head, we're going to be limiting for the swing 1 and 2 motions. And these are going to be the values. I'm going to be making a document so that you can access, and it's going to have everything there. So you don't need to, so I'm not going to need to like explain everything because that's going to take a lot of time. But if you want to get the same settings as I have already on here, on this mannequin, you can access the link on the description down below, which is going to contain a document that you can access, so that it's going to show you exactly which configuration you should set up in a way that it makes your ragdoll to look realistic, right? So if you want to get the same settings as this mannequin here, just be sure to check out the link on the description down below, so you can access the free document with all the settings, with all the constraints. It's going to be out there, so be sure to check it out. Now, another thing that I forgot to talk about is how you can enable the collision settings, so that in a way that the arms can collide with the belly, the arms can collide with the leg. Because if you try to simulate a normal ragdoll, like let's say the UE5 mannequin, for example, let's see if this character has collision. Yeah, it has all the collision set up. But if it didn't have, we could disable collision here on this button, and let's try to simulate again. So as you can see, the legs are passing through each other because we don't have the collision enabled setup. So to do that, to enable the collision, we are going to select each of these physical shapes and select the other one and enable collision. We're also going to do the same step for these ones right here. Let's just do that for the legs, for example, on this example. So we're going to simulate again. And now let's try to get the legs to be with each other. So as you can see, now the legs are colliding with the other leg. And that's how you can basically set up the collision between the other physical body shapes of the character. So that's how you do it. So once the ragdoll is all set up, we're going to be moving to the blueprints part. So the first thing we're going to do here on the character's blueprint, we're going to add a new physical animation component. And here on the event begin play, we're going to add and drag and drop the physical animation to here and get the node called set skeletal mesh component. Now we're going to get the mesh. So that way the physical animation component can know which mesh basically we're going to be working with, right? Now we're going to be preparing the character movement and collisions for the ragdoll. So for that, we're going to create the ragdoll start function. So the first thing we're going to do, we're going to drag and drop our character movement and set the movement mode so that the inputs are not going to interfere with the ragdoll state. Now we're going to drag the capsule component and set collision enabled to be no collision. So that the capsule does not interfere with the ragdoll physics collision. Now we're going to get the mesh of the character and set collision of that mesh. Set collision object type to be physics body. And we're also going to enable the collision if it's not yet. We're going to set collision enabled and collision enabled query in physics. So this is just for preparing the character movement and collisions for the ragdoll. Now for this part, it's going to be simulate physics and update variable. Now we're going to follow up with the code. Now here we're going to set all bodies below simulate physics. So we're going to want to simulate all the body physics of the character. We're going to simulate sorting by the pelvis. So we're going to write here, make literal name, and write pelvis. So that when you do this, when you simulate the pelvis, what you basically doing is simulating all the body physics of the character, excluding the root of the character, which is this sphere right here. This sphere right here serves for basically in the code we can retrieve its location instead of just getting the velocity of the character from the code. We can get the velocity of the root bone of the character, which is the sphere right here. So in this case, we're getting the root physics asset velocity instead of getting the actor velocity, which is not calculated. Which is not calculated by the engine when the character is ragdolling. So that's why we needed the root physics body, which serves for us to calculate the velocity of the character basically, and make and use that information, that velocity information, to make other calculations that will serve for making the ragdoll even more realistic. So after this, we're going to set all the bodies below physics blend weight, and this determines how much blend we want the physics of the character to be. Now, of course, we want to have the full blend, so this value is going to be 1. And the bone name is going to be the same as the pelvis, because that value is going to be applied to all the bones of the character, excluding the root, because we don't need that. So we're also going to skip custom physics type. And here we're going to create a new variable called should ragdoll, just so that we can access this variable later in the animation blueprint for switching states. Okay, so we're going to be doing that later. And we're also going to set it to be true, because we are going to be we're going to have to switch the state as soon as this function starts. So if you click on play and press F, let me see. Yeah, I have to drag and drop that function to here. So let's get the F key and get the ragdoll start function. And plug it into here, compile, play. As you can see, the ragdoll is very soft, as you can see right there. And the other problem that we have is that the camera does not follow with the character, and that's because when you simulate the physics, the actual actor location and the capsule component stays in that location, and the mesh simply dislocates and moves away from that capsule. So before we can execute the ragdoll, we're going to firstly check if the character is already in the ragdoll mode. So get should ragdoll, or I think this variable should be called is ragdolling, for example. If it's false, then we can start the ragdoll. All right. All right. So now the next thing we're going to be doing is create the function called Ragdoll update. So now we're going to be creating the next function, and this function is going to serve as just for updating the ragdoll. The first thing we're going to do is get a sequence, and then we're going to get a node called physics linear velocity. So here it already has the mesh connected into here of the character, and it asks for a bone name to calculate the velocity, right? So here we're going to be selecting the root bone to be calculating the velocity of that bone. And we're going to promote this velocity to a variable. So let's get this to be called last ragdoll velocity. And the next thing we're going to be doing is to get the last ragdoll velocity. We're going to get the vector length. And here we're going to be getting the map range clamped node. For in range A is going to be 0, and in range B is going to be 1000. And for range A is going to be 1000 as well. In range B is going to be 2800. And all those is going to be connected into a node called set all motors angular drive parameters. So this node here, the higher the value that goes into the in-spring float input, the more likely the character will lie on their back. This is because the joints become more stiffer, so it makes it easier for the character to stabilize himself after high-speed impacts, while also improving the blending when transitioning into the standing up animation. While also improving blending when transitioning into the standing up animation. And in this setup here, let me just connect into here. So in this setup here, we use the last ragdoll velocity, calculated using the root bone as the reference, right? And the velocity vector length is retrieved and mapped to a specific range of values using the map range clamped node. Right, and these mapped values are then used as the in-spring parameter for the set all motors angular drive parameters function. All right, and this allows the character joint strength to dynamically adjust based on the ragdoll's velocity, right, which is calculated by retrieving the root velocity. And this will ensure the smooth and realistic transitions. And these values right here, it's going to be up to you to decide which one is the best. I've tested a lot. I've made a lot of testing and iteration with these values, and just basically have to switch and like try to test on your own what's basically the best value that's going to fit your needs. So now after that, we're going to finally apply the physical animation settings below. So we're going to get a node called apply physical animation settings below. And here's going to be the spine 05. This one is going to be the thigh. This is going to be the thigh R. This is going to be the hand R and hand left. So as you can see, we have an error here, but it's going to be fixed very soon. So just a little bit of recap. These codes are going to be used to provide precise runtime control over the orientation and positional strength of physical bodies, allowing for dynamic adjustments during gameplay. So we're going to be setting up the first custom strength, which is going to be set for the spine 5, physical bodies and below. Okay. So if you don't understand the hierarchy of how the physical bodies are, basically if you simulate the pelvis, for example, as you can see here, it has a T form. So basically if you simulate the pelvis, you're going catch up all the rest of these physical bodies below, because it's within that hierarchy, right? So if you simulate the pelvis, you're going to simulate basically all these bones right here below, right? Now, if you simulate the upper arm left, for example, you're only going to affect the hierarchy below. So you're going to simulate the upper arm L and lower arm L and hand L, hand left, right? So that's just a brief example of how the hierarchy works. So if you simulate the upper arm, you're going to simulate all the rest of the bones, ending on the hand left on this case. If you simulate the spine 5, you're also going to simulate until the head, right? So you're going to basically simulate all these bodies here. So to do an example, I'm going to simulate the spine. And as you can see, all the rest of the physical bodies that are not in that hierarchy, they are locked. And all the physical bodies that are within that hierarchy is going to be simulated. So we're going to get to the last ragdoll velocity. We're going to get to the vector length. We're also going to get to the map range clipped. And here we're going to be dragging off the physical animation data and get the make physical animation data so that you have access to these options here. We're going to be updating these values at runtime. So this is going to be connected into orientation strength. And we're going to get a second node plugged into the value here. And the return value is going to be for the position strength. And the other one is for the orientation strength. I'm going to collapse this to a node so that it becomes easier to read. So I'm going to call this custom strength 1. So we're going to be defining the custom strength 1 for the spine, thigh, left and right. But for the hand R and left, we are going to be defining another custom strength, which is going to be the second one. So you just got to duplicate this one right here and call it custom strength 2 and connect that physical animation data to here. All right, now let's set up the values for the custom strength 1. Actually, we don't need this node right here. Let's delete that. For the in range B, we're going to do 500. And for the out range B, it's going to be 1000. Now for the custom strength 2, we're going to be setting the in range B to 500. The out range B is going to be 1000 as well. And for the second one, for the position strength, is going to be 500. And for the out range B is going to be 200. Now, these values that I think I found that it's going to be the best values that you can get for the physical animations, especially for the flail effect. Now, if you have other animations, maybe you need to tweak these values to see which one works best for you. So you can leave out of that. And the next thing we're going to be doing is, out of the 3, we're going to get and set the enable gravity. And here on this case, we're only going to disable gravity if the character is falling faster than less than 4,000, which is to prevent continual acceleration, right? This also prevents the ragdoll from going through the floor. And let's get the last ragdoll velocity. And let's get this, if this is equal, actually let's split this and get this if it's more than 4,000 negative, then we're going to set the gravity to be enabled. Now the next thing we're going to be doing is to update the actor location to follow the ragdoll. So when you press on play here, as you can see, the camera is not following the ragdoll. So to fix that, we are going to create a new function called set actor location during ragdoll. Now we're going to get a sequence, so just drag off this and press the letter S on the keyboard to get the sequence. And let's get the socket location get socket location of the mesh. And for the socket name, it's going to be the pelvis. So we're going to be setting the pelvis as the target location for calculating for doing the other calculations. So this is going to be the target ragdoll location. We're going to be using this as a base for calculating the other codes. Now for the next code, we're going to be determining and basically determine whether the ragdoll is facing up or down and set the target rotation accordingly. So we're going to get the mesh and get its socket rotation, get the pelvis, split the structure, and if this is less than 0, the ragdoll is facing up. So ragdoll face up. And if this is, and we're going to be subtracting this one right here, and we're going to basically select the float. Select float, but with a different time selection. This time is going to be different. It's this one right here. And we're going to plug this one to here. Finally, we're going to be making a rotator and finally define the target ragdoll rotation. Now for the next step is going to be, we're going to be getting the line trace by channel. For this one, we're going to be getting the target ragdoll location, break the vector, we're going to get scaled capsule, get scaled capsule half height. So for responding the line trace by channel, we're also going to be using, it's also going to be based on the location of the capsule component of the character. And this is going to prevent the lower half of the capsule from going through the floor when the ragdoll is laying on the ground. For the draw debug type, for testing purposes, we're going to be using the for1 frame. And we're going to get and break the hit result. And here, out of the blocking hit, we're going to get the ragdoll is ragdoll on ground. So if this is true, the ragdoll is on the ground. Now then we're going to get a branch. Now for the impact point, we're going to split because we're going to get the Z axis location, subtract this one, and get the hit trace start. We're going to want to get the absolute float of this value right here. Subtract it again. Get the same as this one right here. And then we're going to be finally make the final vector, which is going to then be connected to the set actor location. So this is all going to be for setting the location of the capsule and not make it to go through the floor when you're doing so, when the character is ragdolling. So all this is for calculating where the capsule of the character is going to be when the character is ragdolling. I hope this works. Now let's get the set actor rotation and get the target ragdoll rotation variable that we just created before in here, so that it's also going to update which rotation the capsule is going to be rotated at when the ragdoll is also rotating. Now, if it is false, that means that the ragdoll is not on the ground. So we're going to set actor location again. And let's just get the target ragdoll location and plug that into here. And also copy this one and paste it in here. So that we have different codes and different calculations for whether the character is either on the ground and also for when the character is not on the ground. So now let's test it out and see if it works. Yeah, the engine crashes. Yeah, we have this problem that Epic Games, I think, doesn't know about, is that if you don't disable a option that comes with the game animation sample in the Unreal Engine 5.5, the engine will just freeze or crash. And this is because we have a node connected into the begin play. And by disconnecting this node, the problem is going to be fixed, right? So I'm going to close the engine and reopen it so that we can fix this bug. Gasp physics tutorial. All right, let's try to open it up again. So for fixing that bug, the only execution line that you have to disconnect is this one right here. I don't know if by just disconnecting this one right here, the bug is going to disappear. So let's test it out. Yeah, okay. Now the ragdoll update is not here. Let's drag and drop the set actor location during ragdoll function into here and compile and press and play. Now for the event graph, we're going to drag and drop the ragdoll update and plug that into here. And we're only going to update this function right here if the character is ragdolling. So we're going to get that function there and go to the branch and press F. As you can see, and the character is now stuck on the floor. It just disappeared. But now we don't have the engine to be freezed or crashing because we have disconnected these add tick prerequisite component, which together with the physical animation component and with physics enabled for the character makes the engine to crash. And I'm not sure if this is going to be fixed very soon, but in the Unreal Engine 5.4 version for the game animation sample, we don't have this function right here. So now let's check out why the ragdoll just glitched through the floor. Yeah, this is not the last ragdoll velocity. It's going to be the target ragdoll velocity. I missed on that. Sorry about that. So let's connect this to here. And connect this to here. And compile, save, and test it out again. So when you simulate the physics, now the character is on the floor. And now the camera, as you can see, the camera now follows the character. Whatever the place the character falls into, the camera is always going to go into the direction of the player. So this is already looking nice, but to make it nicer, we are going to be simulating and playing the physics at the same time and playing the animation at the same time. So for doing that, we are going to go to the animation blueprint of the character, animation graph, and we're going to create a new state machine only for the ragdoll. Now we're going to be creating a new state machine for the character. This is going to be called a Ragdoll state machine. And we're going to blend poses by bool. For the blend type, we're going to be choosing the Hermite cubic in and out, just so that we have a nicer movement transition. For the true blend time, we're going to be setting this to 0, and for the false blend time, it's going to be 0.5. Now for accessing the variable that is inside of our character's blueprint, called isRagdolling, we're going to get it by accessing the property access inside the animation blueprint. So we're going to get the property access and get the isRagdolling. Firstly, get the sandbox character variable and get the isRagdolling and connect it to the active value. Now inside the state machine, we're going to be creating a new state called flail. And we're going to be getting the animation called UFN flail, which is basically this one right here. Now let's test. I think we can test it out and see if it works. When you press the F button, as you can see, the character falls pretty realistically. So now for making the character to stand up, we're going to create another function called Ragdoll.End. And the first thing for making the character to stand up in the animation blueprint, we're going to need to capture a snapshot of the current ragdoll pose to use in the animation graph for smoothly blending out of the ragdoll state. So for doing that, we're going to be creating and getting the mesh and get the anim instance. We're going to get a node called save pose snapshot. And for the snapshot name, we can give a name like ragdoll pose. Compile, save. We're going to get a sequence. And for the second code, it's going to be like if the ragdoll is on the ground, it's going to serve as if the ragdoll is on the ground. We're going to be setting the movement mode to walking and play a get up animation. Now, if the character is not on the ground, then set the movement mode to falling and update the character's movement velocity to match the last recorded ragdoll velocity. So yeah, if the ragdoll is not on the ground, then we're going to be setting the movement mode to falling and update the character's movement velocity to match the last recorded ragdoll velocity. So for doing that, we're going to go and get a branch, and we're going to get the ragdoll on ground boolean variable state. We're going to do two conditions: if the ragdoll is on the ground and if it's not. So if the ragdoll is on the ground, we're going to be setting the movement mode to be walking. If it's not on the ground, it's going to be falling. Now, if the character is on the ground, we're going to play the montage of the character to stand up, right? So we're going to do montage play. montage play. Let me see if I can get the, let's get the mesh of the character, get the anim instance, and get a node called montage play. There you go. Now I have two animations here from ALS. One is getting up like this, and the other one is get up from the back. Right, so one is the front, get up from the front, and the other one is from when he's laid down on the back. And we're going to be creating the montages. So get up. So we're going to be creating the montage, and for the back as well. Now here, if you click on the montage, we're going to be setting up the blend in physics, not physics, the blend time and the blend mode, right? So for the blend time, the blend in, we're going to be setting that to 0. For the blend time is going to be 0.3, and this one is going to be cubic. So that's just for setting up so that when the character stands up, the blending looks a lot more realistic and smooth. And we're going to do the same thing for the other animation. We're going to set that to 0, and we're going to set that to 3, and it's going to be cubic. All right. So here we're going to be selecting based on, we're going to select the montage based if the character is facing up or down, and here is going to be get up from the back. And we're just going to be selecting those animations. And the character movement, we're going to be updating its velocity. So we're going to set the velocity to be based on the last ragdoll velocity. Now, if you try to do that right now, in the event graph, we're going to search for the branch and drag and drop the ragdoll end, just to see what happens when you press play and then try to do the ragdoll and press F again. Nothing happens. I think it's because we don't have the... Okay, it's because is ragdolling has to be false. Like this. So when you press on play and do the ragdoll, if you press F again, yeah, you have to set up some things for the character to get out of the ragdoll state before we can actually play montages or any other animations for the character. So we're going to get out of the third pin here. We're going to set the collision enabled for the capsule component. We're going to set it to be collision enabled. And for the mesh, it's going to be object type. This one is going to be pawn, and set collision enabled to be query only, no physics collision. Set all bodies below, set all bodies, simulate physics. It's going to be false. And then we're going to be finally updating the variable called isRagdolling so that we can switch states inside the animation blueprint of the character. So when you press on play and do the ragdoll, press on F again. As you can see, the character has a very bad blending. That's because if you go inside the state machine, we only have the flail state in here inside the state machine. So we're going to create another state called, I don't know, snapshot. And we're going to transition back and forth. And this transition here is going to be, we're going to access the variable inside the sandbox character, which is called should ragdoll. Is ragdolling. And if it's not ragdolling, then we can enter the transition of the snapshot. So remember that we saved the pose from snapshot. So we're going to be using that pose in here. And by doing so, for doing that, we're going to get the pose snapshot, and we're going to get the same name of that snapshot name that we've set in here. So in this case, it's ragdoll pose. We're going to copy and paste and plug that into the result. So as soon as this pose is captured, we're going to be using that pose to blend out and go into the stand-up animation, from the ragdoll to the stand-up animation. Final thing that you have to do here is go back to flail if the character is ragdolling. So I'm just going to copy and paste from this property access node here. If we're going back, it's going to be connected into here. And if we press on play, let's test it out to see if it's working. So press again. Yeah, I think we are missing just one step, just one single step, which is to set up the duration of the transition rule. So this one is going to be 0. This one is going to be 0 as well. I think that's pretty much what all you have to do for the transition rule blend types, blend modes. Right. So if you ragdoll and then try to get up, as you can see, we have a nicer, smoother animation of getting up. Now, of course, you can change the play rate because the character is a little bit delaying. The animation is a little bit slow, so you can always change the play rate of the animation depending on your project's needs. All right, so that's pretty much it. I hope you enjoyed. So if you want to stay for making the moving platforms, then you can stay on for the rest of the video. So now we're going to be learning how you can make the moving platforms blueprint so that the character can collide with it. Just test and see how the ragdoll is going to behave on certain conditions. So we're going to go ahead and create a new blueprint class. It's going to be an actor. And this is going to be called BP moving platforms. I'm going to add a new static mesh. And this, in this case, is going to be the SM cube. And I'm going to add a new box collision. Now for covering that box with the other box, I'm going to go to the right perspective and just place that into here. Let me just remove the limitations of moving with the box. And I'm just going to fit that in here. Now let's go for the front perspective and just align that with the box. Now if you click on the static mesh and go to collision presets, we're going to choose no collision. And I think it's better for choosing the custom and ignore all the collisions, because the box is going to be what's going to be matter. The trigger box is going to be what's going to collide with the character. So if you click on the box, you're going to go down to begin overlap. We're going to basically check here if, in case the box enters in contact with the character, then we're going to be simulating the physics of the character, right? So for doing that, firstly, we're going to be out of the event begin play. We're going to cast to CBP character. So CBP cast to CBP sandbox character. We're going to try get player character. We're going to update that to a variable and call this CBP. Now for the other actor, we're going to say if the actor whatever actor that the box collider hits and enters in contact with something, we're going to be checking if that same actor is our character, right? So we're going to get that condition, and if the condition is true, then we're going to execute the function of the ragdoll start, right? The same function that happens when you press F so that you can start the ragdoll. All you gotta do is just execute that ragdoll start function inside the character's blueprint. So going back there, we're going to get out of this, the CBP sandbox character reference. So we're going to get the ragdoll start. And that's basically all you gotta do. Now, if you move the moving platforms into here and try to collide the character with it. Yeah, I guess the moving platforms, we're going to set the collision for blocking everything. Let me see. Collision enabled is going to be collision enabled. Query and physics. And yeah, that's going to be the physics simulation. It's very fun. Now, if you want this block to move, to be moving in the world, you can do that by getting the actor location and saving that in the event begin play. So let's say this is going to be the initial location. I'm going to add a new timeline. And in this timeline, you're going to basically choose the time that the block is going to move. So here you're going to be setting up the time. So you can press and hold the left shift and left mouse click to add a new key. And for the time, it's going to be 0.05. For the value is going to be 1 in here. And here the value is going to be 0. And the time is going to be 4. Now we're going to select everything, right click and go to auto and press F on the keyboard to visualize and focus better so that you can see the curves that we've just placed in here. Now, if you go back to the event graph, as we want the block to continuously move, I'm going to set a delay of 2 milliseconds. That's going to go and cause it to go back to play from start, which is going to cause the loop effect, right? So the block is always going to be moving. Now we're going to be setting the actor location based off this value right here on the lerp vector. Add 2,500 units for going on the x-axis. I don't know exactly which direction that's going to go for, but if you want to get in the other direction, you can do y instead of the x. So let's test it out and see if it's working. Now, as you can see, the block is going to be moving into here, here and there, and then you can just collide with it. And that's pretty much it. I hope you enjoyed. If you have any questions, you can comment down below. Be sure to check out my document that I'm going to do and let down the description below so that you can access and get the same physics body that I have here in order for you to set up on your own project. So that's going to be it. I hope you enjoyed. If you have any questions, comment down below, and I see you in the next one.